Hi, this is Anil from Learning Lad with a video tutorial on C programming. So in this tutorial we're gonna see about the dynamic memory allocation. So in this tutorial I'm gonna explain what is dynamic memory allocation and what is the need of this dynamic memory allocation. Dynamic memory allocation is nothing but the process of allocating memory when the program is running. You are gonna allocate the memory when your program is running. The operating system is the one which is gonna do the memory management, so it's gonna allocate enough space in memory for each program to store its variables and data, and these memories are called stack. So we can say that the operating system is gonna reserve some part of the memory as a stack where the programs running in the system can store their local variables and data. So let me see whether I can draw this. Okay, now let's say this is the stack allocated by the operating system for the programs to store their local data, and the stack is shared by all the programs running in the system, and this is the stack space used by the program 1 to store its local variables and data, and let's say this one is for the program 2. And similarly, if any other programs are running, they're gonna use the remaining stack memory. So in our program, when we create and use a variable, for example int x, and when we use that variable by assigning some values to that variable, let's say x, what happens is the variable x will be pushed into the stack. So let's say ours is program 2. It's gonna push this variable x to the stack here. So the variable x will be here, and when we create some other variables and use that, for example float p, and let's say a value of 6.3, and the variable p will be pushed into the stack. Similarly, if we create any functions in our program, let's say we have a function called void add, and this add function is going to create and use some variables, let's say int a and float r, and when we call this add function in our program, the control will be transferred to this add function, and the variables a and r will be pushed into the stack. And also, since this is the memory allocated for the program 2 to store its local variables, this memory will be shared between the functions of a program. So now the compiler is gonna push the variables a and r, so it's gonna be a and r. So once this add up function finishes execution and the control will come out of this add up function, these values a and r will be popped up from the stack. And again, if our program uses any variables or calls any functions, the particular values will be pushed into the stack, and when they finish execution, the values will be popped out of the stack. So in the end, when this main function finishes execution, all these values will be popped out of this stack, and this stack memory will be free. And if any other program is executed, then it's gonna use this freed memory. So the limitation with the stacks is, suppose let's say in our program we're gonna use a very large variable, let's say char data, and this data is around 1000 bytes long, and when we use this variable data in our program, the variable data will be pushed into the stack, so that the data will be here, and it's gonna allocate 1000 bytes for this variable data. So at that time, it may exceed the memory space allocated for this program 2, and it may overwrite the memory allocated for, let's say, program 1. And when the program 1 is running along with this program 2, its local variables are changing from an external program, and this program 1 is gonna crash. So as a programmer, you don't want to crash any programs. When your program needs very large amount of memory, what you can do is you can allocate that memory from an entirely different memory part provided by the operating system, and this is called heap. And this heap is nothing but a chunk of large unused memory, and this unused memory can be used by any program running in the system. So we can create a pointer in our program, let's say char ptr, and we can allocate the memory dynamically from this heap, and we can make our pointer ptr to point to that allocated memory. So we're gonna create a pointer here, ptr, and then we're gonna make that one to point to the amount of memory we required, which is allocated from this heap. So for this purpose, we're gonna use some memory allocation functions in C. And once we have done with this allocated memory, we need to free this memory. So if you forget to free this memory, any other program running in the system can't use this memory. And another use of dynamic memory allocation is, sometimes we don't know what is the length or size of the user input. So at that time we can ask the user about the length or size, and depending on that user input we can create enough memory using this dynamic memory allocation technique. So in the next tutorial we're gonna see what are the functions available in C to allocate the memory dynamically, and also how we can free the allocated memory. So this is it, guys. This is about the dynamic memory allocation. Thank you for watching, and don't forget to subscribe to my channel. I see you in the next tutorial.